Okay, here we are back with section 4.4, and this would be part 2. So we're on 4.4, part 2 of the fundamental theorem of calculus, day 1 stuff. And what we need to do on example 3 here is find the area of the region bounded by the graph 3x squared minus 2x, the x-axis and the vertical lines x1 and x4. So this is giving all our boundary stuff. And so we've got a parabola, don't we? And here is our left bound and our right bound. Well, I'm not even going to draw a picture of it. I just want to say that y is equal to the integral from 1 to 4, my lower boundary to my upper boundary. Those are the x vertical bounds. And then the function 3x squared minus 2x dx. And that should give us the area underneath the curve and between the x-axis. So what do I need to do? Well, I need to invoke the fundamental theorem of calculus. Let's find the integral first. The integral of 3x squared would be 3x cubed divided by 3 minus 2x squared divided by 2, evaluated from the lower limit 1 up to the upper limit 4. Well, we can simplify a little bit here, clean it up. And let's look at this then as x cubed minus x squared. Hey, not too bad. Evaluated from 4 to 1. Putting in 4 first, because for the fundamental theorem it says do f of 4 minus f of 1 from top to bottom. So I'm going to have 4 cubed minus 4 squared. Remember my advice, write stuff down. Throw in 1. 1 cubed minus 1 squared. And I'm looking at 4 cubed is 64 minus 4 squared is 16, area of 48. And you could certainly go and validate that on your calculator. Next, this one's a good thinking problem. It says use the fact that region B, and notice they don't show us which is region B, we have to conclude which is region B here, has an area of 18. And the definite integral from 0 to 2 of f of x dx has an overall value of 35. And we need to use those facts to help us answer the following problems. Well, I think the first thing I'm going to do is mark up my picture and try to figure out where is region B? Well, region B, they tell us that it has an area of 18. And normally, you know, we always express area as a positive. So in my mind, I'm thinking it could either be the one above the curve or below the curve because area is always positive. It's just the value of it when we look at integrals, we call this a negative region. So that does get a little confusing. What I do know in my head is that region A plus region B has to equal some total amount, right? And so I'm going to maybe think of this as region A and this as region B. And we're going from 0 to 2, so it's this entire picture that we should involve. Well, the total they told us on the integral from 0 to 2 is 35. So now I can fill in the 35 portion. If I end up with a positive amount, then A has to be greater than B. And that is what's indicating to me that this B has a space of 18. It's really a negative 18. So I'm going to say A minus 18 is equal to 35. And I went ahead and put a negative 18 over there. Add 18 to both sides, and that makes me conclude then that region A is 53. So 53 minus the 18 gives us the overall 35 that they were talking about for the integral from 0 to 2. Now, it shouldn't be too bad to do this work. The first thing I noticed when I looked at this, and I hope you said, hey, there's something wrong with this picture, 1 is a larger value. It needs to be up on the top. So I need to integrate from 0 to 1 of f of x dx. But in order to make that change of my limits, I need to throw the negative out front when I reverse them. So we're really looking at the negative from 0 to 1. The region that's from 0 to 1 is right here. That's region A. So this must be negative 53. Part B, we are looking at the region from 1 to 2. And then we're going to add 4 to it. Oh, that means this is a vertical shift, right? It's shifting everything up by 4 units. Vertical shift. Going up by 4. So 1 to 2 of f of x dx plus the integral 1 to 2 of 4 dx. Break them into two separate integrals. From 1 to 2, that would be talking about region B. 1 to 2, region B, I know that to be negative 18. Added with, well, I could do the integral of this if I didn't want to think of it as a rectangular region of height 4 from 1 to 2. I could break this into 4x, because I raise it by a power, so I'm at x to the first divided by 1, evaluated from 1 to 2. That makes negative 18 plus, let's do the fundamental theorem, put 2 in, and I'm at 4 times 2 minus 4 times 1. Evaluating at 2, then evaluating at 1. That gives me negative 18 plus 8 minus 4, and that gives us negative 18 minus plus 4, so negative 14, answer to part B. Letter C. We understand that these multipliers, or k values, can be brought out front. So I get negative 2, 0 to 1 of f of x dx. From 0 to 1, look at our picture. 0 to 1, we get an area of 53. So we have negative 2 times 53, giving us a grand total of negative 106. And finally, the last one. This is an interesting one. I'm going to clear off my screen. And let's talk about absolute value. What does absolute values do to functions? They make negative things positive. So any place where y turned out to be negative, it's now going to be positive. And if I look at my graph, these y values were all positive. They are going to be unaffected. Down here in region B, these were all negatives. They actually would be mirrored then and flipped over to the top and created into a positive B space. So instead of being negative 18, I now know that this is equal to positive 18. So I'm going to break this integral into two pieces, and I'm going to look at it from 0 to 1 of f of x dx. And then I'm going to do the opposite of from 1 to 2 of f of x dx to take care of the fact that this was negative area and now make it positive. And this was a positive 53, I believe. So I take 53, add it to 18, and I get 71. All right, so the homework following this section is out of the textbook, 5 through 17 odds, and then a few more sprinkled in there. Please look at the back of your textbook to make sure you're doing these problems right, or verify them using your calculator. We should have time in class to work on this, so just be prepared for tomorrow.